Hello everyone, I'm really glad to see you back again. In today's lesson, we are going to learn how to represent a function using graphs. A graph of a function f is the set of all ordered pairs x, y, such that f of x is equal y. In other words, the set of ordered pairs x, y are Cartesian coordinates of points in a plane. For instance, we can take the function f of x equal 5x and obtain the set of ordered pairs from it by substituting some values. For example, the set of ordered pairs made of 1, 5, 2, 10, 3, 15, and so on. And we can graph the function, which will look like this. I challenge you to do the same for the function f of x equal x squared. Try to take some values x, which are your input values, put them in the function, and the values that you get, the values y, you're going to graph them on the Cartesian plane. And that will be your graph of this particular function. Don't forget to use also negative numbers. Now, let us consider doing the inverse process, meaning giving a graph. Is such a graph a function representation? For example, we will consider the following two graphs, and we will determine if such graphs are functions. Now, the first graph represents a function because it satisfies its definition. For each element x in x, there's a unique element in y for which x is associated with. Nevertheless, the second one is not a function because there are elements x in x with several y associations. Now, there's an easy way to determine if a graph represents a function by using something that we called the vertical line criteria, in which we graph a vertical line, and if such a line intercepts the graph in more than a point, then such a graph does not represent a function. Well guys, that's all for today. Thank you very much for following the entire video. And now, as always, it is your time to put your knowledge into practice by determining if the following graphs represent functions. As well, consider the following functions and try to graph them. And as always, guys, see you in the next video.